Hello, and welcome to our team's video review on corrosion. We hope you find it helpful and that you also enjoy it. Good luck!
Corrosion is a destructive and unintended attack on a metal. Common examples include the rusting of iron or the verdigris of copper. Corrosion is an electrochemical process. Electrochemical processes can occur in all material types. In ceramics, this is called deterioration, and in polymers, it's called degradation. However, ceramics are relatively resistant to deterioration in polymers, and in polymers, degradation is very different from metals. So, our discussion of these processes will focus mainly on the corrosion of metals. What are electrochemical processes? These are basically operations in which electrons are transferred between at least two species, typically a solid and a liquid. Although we may not realize it, this process is going on in our lives every day. The batteries we use follow this very procedure and supply energy, aka electrons, to power our devices. Here, we have two electrochemical processes, the oxidation of the iron atom and the reduction of the iron ion. We'll take a closer look at these in a few minutes.
The redox reaction. The word redox is an abbreviation of the words reduction and oxidation. The redox reaction is the primary electrochemical process responsible for corrosion. In the example here, the bottom equation is the redox equation, which consists of a zinc atom and two hydrogen ions. In this reaction, the zinc atom will exchange two electrons with the hydrogen ions, producing a negatively charged zinc ion and two neutrally charged hydrogen atoms. Although this seems to be a simple example, there are many redox reactions, and it is sometimes difficult to picture which chemicals are gaining and losing electrons. Therefore, we like to break down redox reactions into two half equations, or half reactions if you will. The first of these two electrochemical half reactions is oxidation. Oxidation occurs when electrons are lost from a species. This typically occurs in metals and their alloys as they tend to have valence electrons to give up. The second half reaction is the reduction reaction. Reduction occurs when electrons are gained by a species. This usually occurs in nonmetals. Although these two terms seem unnecessarily confusing, they are easy to remember with the simple acronym oil rig. Oxidation is loss of electron. Reduction is gain of electron.
Electrochemical cells. Electrochemical cells are devices that generate electrical energy from chemical energy through conversions. They operate on the principles of redox reactions, which were previously described. The electrical energy in electrochemical cells is generated from the flow of electrons on an oxidized material over a designated path to a material that will be reduced. Electrochemical cells are ubiquitous and have been incorporated into daily life. Examples can be seen in a normal 1.5 volt battery. Components of electrochemical cells. An electrochemical cell consists of two half cells. Each half cell consists of an electrode and an electrolyte. The half cell with and in which the electrode material is oxidized to generate an electron flow and induce voltage is known as the anode. A good way to remember that the anode is oxidized to generate electron flow was previously stated as fat cat, from anode to cathode, which describes the flow of electrons from the anode to the cathode, which will be explained later. The half cell in which the electrons from the anode reduce electrolyte material to plate the electrode is known as the cathode. A good way to remind yourself of this reduction at the cathode is by the mnemonic device REDCAT.
Thank you for watching our presentation on corrosion. Hopefully, you leave this video with a deeper knowledge on corrosion and all the processes that go into it. Thank you very much, and see you next time.